Have you ever wondered why games with incredible graphics can also have terrible hair? Making realistic hair in video games is notoriously hard to get right. However, making realistic fur is almost unheard of. So when I was recently playing Black Myth Wukong, I was absolutely amazed to see that all of the bosses have really realistic fur. And when I found out that they were using Unreal Engine, I had to figure out how they did it. Let's dive in. Also, hi, I'm Holly. I'm a game developer. I make content all around game development, so if that's your thing, I would love to see you stick around. So why, in the year of our Lord and Savior in 2024, can we not get realistic hair in video games? Well, it's because generally the more objects you have in your scene, the slower your game is going to run. And with something like hair, just one human head has 100,000 strands of hair on it, which is potentially 100,000 objects to render just for one human head. If I have one object in my scene versus an object with 1,000, I think it's pretty easy to tell which one is going to load faster. The really interesting thing about hair, though, is that it's not just about displaying 100,000 objects. Each one of those strands is going to be affected by gravity, it's going to be affected by physics, it's going to react to wind, but it's also going to react to light as well. So it's a really, really expensive computation for your computer to run. To get realistic hair, game developers have to think about all the tiny things that make hair look right. If I'm in a dark room versus sitting in the sun, my hair is going to be a little bit different. It's going to reflect some light, but it's also going to let some light pass through it. And if I'm running versus sitting down, my hair is going to react differently as well. And if I'm running in the sun, well, I'm a game developer and I don't go outside, so I wouldn't know. Take 100,000 objects, add physics and lighting calculations onto them, and you are going to beach ball your computer. And that's just for head hair. But what about hair all over the body? There is surprisingly little information about making realistic fur in video games right now because it's so new. So I had to start with head hair and kind of work my way there. In order to achieve anything close to reality, game developers have to fake it. Fake it till you make it, I guess. Some games don't use hair at all, but more like sculpted clay versions of hair. Think of like Animal Crossing, Zelda, even The Sims. That way you're not dealing with strands of hair at all, you're really just dealing with one object and you can kind of add some different physics to it. Some take it one step farther, so it's kind of like a clay sculpted hair, but you print an image on it or multiple images onto the hair. A really good example of this would be like The Sims. So you kind of have that clay hair, but then you also have just a tiny bit more realism. But what about for realistic hair? Hair artists in games, yes, there's an entire job for that, use a series of tricks to cut down on the computational processes of this. For instance, back when I was in high school, there were these donut-shaped things for hair buns everywhere. You put your hair up, you put your hair in the little donut. Doesn't matter if you got 5 strands of hair on your head, but you're gonna have a pretty good looking bun right after that. But in that instance, you don't really have to render what's inside the bun. You just have to render the hair on the outside. So why make it more complex than it needs to be? Basically, who cares if that weird chunk of hair that's on the back of your head gets rendered or not? Nobody's gonna see it anyway. It just has to look realistic from the outside. Same thing like if I have a braid, and you'll see braids a lot in hair video game design because one braid kind of just acts like one big chunk of hair. If we're thinking about like really fancy hair, like the type that Aloy has in Horizon Zero Dawn, this type of hair is made using something called hair cards. And these are essentially just sheets of images with hair printed on it, and they are carefully placed around a model. And instead of using strands of hair, we use big sheets because we're operating under the principle that if I have 2 hairs that are right next to each other, they're probably going to react the same. You have different variations in the sheets, you have different lengths, you have different colors, and you end up with something that looks like hair. If you've ever seen clip-in hair extensions, this is exactly what it looks like. Who would have ever thought that my hair knowledge would apply over to my game development knowledge? Not me. And I realize that my analogies are a little niche, but what are you gonna do? And if you just so happen to be in this niche and you've messed around with clip-in hair extensions, you know that it doesn't look that great, it takes a lot of time, and it just kind of sucks. And this is the exact issue that game developers face. It's clunky, it takes a lot of time to get good at, and it's just very limiting. You basically have to be a game artist and a hairstylist, which are two entire jobs. Enter the Strand approach, and this is kind of where hair and fur start to combine. And while the Strand approach has a fancy name, all that it means is that every single strand of hair is accounted for. So it's trying to be one-to-one with how your hair actually is. Instead of the fur being manually placed or kind of clipped in, it's more brushed on, very similar to a terrain tool. So it's a lot more akin to painting grass on a hill than it is hair extensions. From there, you can manipulate the color, the density, how long it is, the direction of the hair, different patterns of the hair. It's really quite amazing. And this offers so much more flexibility and realism because even on the same body, not all hair is created equal. Hair doesn't just grow out of the body like a chia pet. It grows in patterns, it grows in different areas, it grows in different directions. And the only real hiccup here, and it's a major one, is that especially with animals, you're not just talking about head hair, you're talking about potentially millions of strands of hair just on one animal alone. And while you can have super detailed models, just like the one in the Meerkat video when it comes to like cinema or movies, you can't really do the same thing in game development. And here's why. When it comes to movies, I can make an animal as detailed as I want it to be, and then I hit the render button, and then I just have to wait for that movie to render. And it may be a long time, but I don't have to worry about real-time physics and gravity and all of those things like that. I can deal with that ahead of time, whereas in game development, it has to be immediate. It has to be right now. If wind blows in the game, the fur needs to react. If the boss hits me and then the wind blows, it has to react a certain way. And there's probably thousands of variations of things that have to happen right now. So you really don't have any grace at all when it comes to processing. So again, we have to find ways to cut back on this and to kind of fake it to make it look realistic. One of the biggest challenges when it comes to hair is the number of vertices. So if I have a straight hair, I have basically two vertices. I have vertex A and then I have vertex B. But if I have like wavy or curly hair, I may have 5 vertices, but more likely like 10 or 15 just on one single strand of hair. So you are increasing the computational processing needed by 10-fold just by having something like wavy or curly hair. So in general, making hair as short and straight as possible is going to cut down on the computational processing. However, the more you cut down, the less realistic it becomes, because not all animals are going to have very short, straight hair. Again, we're not dealing with chia pets, we're dealing with living beings, so there's always going to be that threshold that you need to kind of hone into on what really makes sense for a game. And on top of that, you can also cut down on the processing by decreasing the density and increasing the width of the actual hairs. If I increase the width of the hairs from 1 to 1.3, to the human eye, it may not even make a difference, but I may be able to, with that, decrease the density and have it look pretty realistic for games. But of course, anything that strays from actual realism, there's going to be a cutoff point where it doesn't look realistic anymore, so it's really a balancing act of balancing quality with performance. However, this is really where Unreal Engine starts to come into play. Everything we've talked about up until this point really hasn't had anything to do with Unreal. You can actually do all of the grooming and all of the hair in other softwares. The actual grooming tool inside of Unreal is pretty primitive, and they're very straightforward about that, but they have other things that you can do with your existing groom. One of the things that it does is that it clumps hair together that are in similar sections, and from there it will determine what needs to be rendered first. Again, we're kind of operating on the principle that if I have 2 hairs that are next to each other, and maybe 3 hairs, and maybe 4 hairs, all of those are gonna kind of act in a similar fashion. We just need to find a smart way to be able to determine what hair is going to react similarly and what hair is going to react differently. For instance, if I have two pieces of hair and one piece of hair is in front of the other piece of hair, Unreal Engine knows to render the hair that is in front first. Because again, if I have hair that I can't see, or even in that case where I probably would be able to see it, it still matters that the hair that's in front, that is more important than the hair that is in back. So it has a really smart way of determining what hair takes priority. And this is referred to as culling. Every single game that you play uses culling. And all it means is that we don't want to render something that doesn't matter right now. If I'm a player and I'm playing on one side of the map, I don't care what's going on the other side of the map. I don't need it to be rendered by my computer right now. When I get to that side of the map, absolutely want to see it. But anything outside of what I am currently looking at, I don't care to render, it doesn't matter. Games actually do this by basically anything that my camera can't see, that is not being rendered. As soon as my camera sees it, we're good to go. Similarly, if I have an enemy and I'm approaching an enemy that has realistic hair and fur, but it's over there, who cares if all of its hair gets rendered at the same time? I don't need to render all of the detail for the hair immediately. I can kind of put it in as I get closer. And this is called LOD, or level of detail in games. And it's the exact reason that when you are launching down in a battle royale like Fortnite, you gradually see different areas of the map pop in, and it gets slowly more detailed as you go along. And that's because if you tried to load everything all at once, it would take a lot of processing power and your game's gonna lag, and you're not gonna get that crispy 60 frames per second. And what's so cool about this is that we are just at the very, very beginning of this. We are on the bleeding edge of hair and fur technology. And what's made this really possible just within the last few years are the insane capabilities of modern PCs and modern consoles, but also the really amazing work done by game developers to make these assets and to push the needle forward. But I want to know what you think about all this, so thank you so much for watching. I hope you learned something, I hope you enjoyed it, and I'll see you in the next one.